10.6 is our last section on conic sections. We're going to learn how to identify conic sections based on the equation that you're given. So we have these big long strings of equations like you've seen in other places in the book. And for our intents and purposes, we aren't going to have any bxy term. We will never have the x and the y multiplied. For the record, if you have a bxy term, I can take an ellipse and put it at an angle, or change, graphing is kind of weird, so I'm going to work that. Change the angle at which a hyperbola is graphed. Those bxy terms add some eccentricity to these conics, but we're going to play with those. So without doing any arithmetic, which would involve completing the square, I can tell if an equation is going to produce a parabola, a circle, an ellipse, or a hyperbola by following this little flow chart. Now the book, the way that the book gives you, I say it's stupid, it's really fine. It just does the discriminant, which if you remember is b squared minus 4ac, and compare a few things by doing b squared minus 4ac. But I've developed this fun little flow chart. It all comes down to identifying your a's and your a and your c terms. So right now my a value is 3, my c value is 3, and then d would be negative 12, e would be 18, f would be 5, and have no b term, b value is 0. The first questions are both x and y squared. And since I have an x squared and a y squared, the answer to that question is yes. If I didn't have both an x and a y squared, for example, if this term here didn't exist, if there was no 3y squared, then I would know this equation would give a parabola. The next question, does a equal c? Well, since a is 3 and c is 3, the answer to that is yes. So this is going to be a circle. So now that I know it's going to be a circle, I know generally how circles look. X minus h squared plus y minus k squared equals r squared. I want to take this equation and make it look like that circular form by completing the square a couple times. I'm going to group up my x's, group up my y's, and move that 5 over. On the left side I can factor out a 3. And then here I can also factor out a 3. And equals negative 5. Now I could have divided everything by 3 if I wanted to. For circles that can work. But it's nice to have one method you can follow every time, so we show factoring it out. Here my b value is negative 4. So b over 2 squared is actually positive 4, so I add a 4 here, which was really a 12. So it was 3 times 4. So I really added a 12 to both sides. On the other one, my b value is 6. My b value here is 6, so b over 2 squared is 9. I'm going to add a 9 here, which is really a 27. So, I'm going to stop for a second, make sure this all looks okay. Yep, I think that's fine. Complete my squares, see what happens. So I have 3 times x minus 2 squared plus 3 times y plus 3 squared equals 34. Because I have a circle, I need to get rid of these coefficients, so I divide everything by 3, and I get x minus 2 squared plus y plus 3 squared equals 34 over 3. So I know that my center, not that it asks for this, but my center is at 2, negative 3, and my radius is the square root of 34 thirds. Whatever that is. Good. Next one. I'll keep that flow chart up here. Next one, 4x squared minus 6y squared plus other stuff that I don't really care about. Are x and y both squared? Yes. Does a equal c? No, because a is 4, and c is negative 6. So a does not equal c. No. Next question, do a and c have the same sign? One of them is positive, one of them is negative. So again, the answer is no. Since the answer is no, this is going to be a hyperbola. So, I'm going to put this in hyperbola form. Now I know that a hyperbola is x minus h squared over a squared minus y minus k squared over b squared equals 1. The x's and the y's could switch spots. It could be y minus k first, then x minus h. So I'll figure that out when I get there. So I get my x's together, my y's together, and move that negative 22 over there, so I have this. I'll factor out a 4 from here, so I have x squared plus 2x minus 6 times y squared minus 6y equals negative 22. Calculate b over 2 squared. So here, 2 over 2, b over 2 would be 2 over 2, which is 1. Squared is still 1, so add a 1 here, which is really a 4. And I'm going to add a 9 here, which is really a negative 54. Now I'm going to complete my square. Back to orange. 4 times x plus 1 squared minus 6 times y minus 3 squared equals negative 18 minus 54 is negative 72. Now, because this is an ellipse, I need it to be equal to 1. So we're going to divide everything by negative 72. And that just involves reducing. I'm just going to reduce this fraction. So 4 over negative 72 is really negative x plus 1 squared over 18. 6 over 72, well, negative 6 over 72 becomes positive y minus 3 squared over 12. Now you'll notice the negative is here and the positive is here. So I'm going to switch the order these things come in. I get y minus 3 squared over 12 minus x plus 1 squared over 18. And this equals 1. And there is the equation of my ellipse. It would have a center at negative 1, positive 3. It would move left and right root 18 units, up and down root 12 units. I draw my box, make my asymptotes graph. There we go. That's identifying conics, and that takes care of the chapter.